Let's now turn to cognitive load theory. The guiding questions for this unit are as follows. What are the assumptions and key concepts of cognitive load theory? What principles and implementation strategies align with cognitive load theory? And how do we approach assessment using cognitive load theory? Let's start with the assumptions and key concepts in cognitive load theory. The key assumption is that we have a very limited working memory capacity. This forms the foundation of cognitive load theory. We know that learning is facilitated when new information is connected to our prior knowledge, simply put, things that we already know about a specific topic or context. We know that learning is facilitated when new information is organized or refers to some kind of mental structure or schema. Again, we call those organized structures schemata. We also know that learning is facilitated when the learner is actively involved in the learning process. So again, you cannot passively receive information and hope that it results in long-term meaningful learning. As a brief review, let's just take a quick look at the essential features of how the information processing model looks at learning and what the specific elements are. So again, this would be a representation of what goes on internally as you take in information from the outside environment via your senses, whether visual, auditory, or any of the other senses. We have a very short-term sensory memory or register that is on the order of milliseconds. So we lose a lot of information at that point because we see and hear a lot of things that don't necessarily make it into long-term memory. But those things that we do attend to make it into working memory, which is significantly longer. And again, that's what we think about as our consciousness. Once in working memory, a lot of information still gets lost, but we can help that by engaging in rehearsal, elaboration, and organization, and a number of other strategies. Using elaboration and organization particularly is the process of connecting information to what's already stored in long-term memory. And that's one of the reasons why prior knowledge is such an important piece of this model. And of course, once information is in long-term memory, then there are also strategies that go along with being able to retrieve it. One of the things that we said about the information processing model is that it alerts us to the fact that there's a built-in human limitation in terms of learning, which is the very limited capacity and duration of our short-term memory. It's kind of like a blockade or a bottleneck in the system, and we all have it, whether we are baby boomers, millennials, or the Generation Z. Cognitive load theory, however, can provide guidelines to assist in the presentation of information in a manner that optimizes intellectual performance. Cognitive load theory is critical for effective design of instruction, such as via training and development. The history of cognitive load theory can be traced back to the beginning of cognitive science in the 1950s in the work of George Miller. In his classic 1956 paper, Miller was perhaps the first to suggest that our working memory capacity has inherent limits. His experimental research suggested that humans are generally able to hold only 7 ± 2 units of information in short-term memory, and nowadays researchers have reduced this capacity to as low as 3 to 5 units. Cognitive load theory was developed to its current state by John Sweller in the 1980s. So let's focus in on the center of processing working memory, right in the middle of the information processing system. This unit in the system is really what needs to be considered when talking about cognitive load. Remember that it's limited in both capacity and duration. Cognitive load theory differentiates cognitive load into 3 types: intrinsic, extraneous, and germane. Intrinsic cognitive load is due to the inherent conceptual complexity of material. There are high versus low complexity tasks. For example, there is an inherent difference in the complexity of simple addition versus quadratic equations. The second type of cognitive load is extraneous cognitive load. This load is due to poor instructional design. An example of extraneous cognitive load occurs when there are two possible ways to describe a cone to a student. Using the verbal medium by explaining what a cone looks like will impose a much higher cognitive load than using a visual medium. In this instance, the efficiency of the visual medium is naturally preferred. Another example of extraneous load is when an instructor assigns a problem-solving task to students but does not provide the necessary materials. So looking for materials such as previous worksheets or lectures about the topic on top of problem solving causes extraneous load. My own example of extraneous load is not having my second screen available. I work much more efficiently with 2 screens than 1. The third type of cognitive load, germane cognitive load, refers to effort in schema construction, sense-making, meaningful learning, essentially being actively and metacognitively engaged in learning. This is a desirable type of cognitive load. The 3 types of cognitive load are additive in that if learning is to occur, the total load of the 3 together should not exceed working memory capacity. Cognitive load theory states that instructional interventions cannot change the intrinsic cognitive load because it comes from the inherent nature of the task. Extraneous and germane cognitive load, however, are determined by instructional design. So what principles and implementation strategies align with cognitive load theory? These are cognitive load principles that can be used to create effective training and development. Let's review each one of them. Remember that you cannot change intrinsic load since it's inherent in the content, but you can manage it by segmenting it into simpler parts and providing some pre-training. For example, when needing to train people in complex software, it might be helpful to teach them the basic terminology ahead of the training session. Decreasing extraneous load is very important in order to optimize learning, and we will share some implementation strategies next. Remember also that there is one type of cognitive load that we want to increase, germane, as it optimizes learning and facilitates construction of effective learning. Here's a graphic to help us think about cognitive load. Since cognitive load is additive, let's think of our working memory as a column with limited capacity. In the graphic on the left, much of the person's cognitive capacity is taken up by intrinsic and extraneous load, which leaves little cognitive processing capacity for germane load. If you were to reduce extraneous load and manage intrinsic load, there is more capacity to germane cognitive processing. Germane, again, helps learning, so we need to create space for it. The graphic on the right shows how much more capacity is available for germane load when intrinsic load is managed and extraneous load reduced. So again, remember that you cannot really reduce intrinsic load, but you can manage it, and you can, through that, create more space for germane load. In this table, we present implementation strategies to manage intrinsic load, reduce extraneous load, and increase germane load. This table includes very specific instructional implications and very specific strategies, all organized row by row. The slide here, though, goes over the broad picture of implementation strategies. So the first strategy is to avoid overloading learners with extraneous and unnecessary information. In instruction, if the learner lacks prior knowledge about a topic, it is important to focus on the must-have rather than the would-be nice-to-haves of information. And with limited prior knowledge about a topic, essentially, less is indeed more. The second implementation strategy says to break content into parts and provide pre-training for particularly complex information. Look at training, for example, as distributed rather than crammed learning in one session. So much better to have multiple sessions than to have one sort of holistic session that can almost amount to crammed learning. The third principle is to integrate auditory and visual information to maximize working memory capacity, as we generally learn more effectively from words and images together rather than words alone. And finally, provide opportunities for learners to engage in guided self-monitoring and self-assessment before, during, and after learning. This enables your learners to become metacognitively aware, active learners, rather than passive recipients of information. Finally, let's look at how we approach assessment using cognitive load theory. We can do this by either observing or asking questions via interview or survey. In terms of observation, we can assess time on task, controlling for distractions, and considering quality of performance. The longer it takes, the higher the individual's cognitive load. We don't know which one, whether intrinsic, extraneous, or germane, but we do know that their load was high. In terms of asking questions via survey or interview, we can ask the learner to rate the amount of mental effort they had to invest in the task, which provides a proxy for cognitive load. The simplest way to do this is to ask your learners how they would rate their mental effort they invested in the task on a scale of very, very low mental effort to very, very high mental effort.